Okay. Oops, what is? That's just that, okay. So welcome to class and. Sorry, I forgot to record last week. We're now in Thursday of week 3. And I'm doing a quick thing about in Moodle that these blue books, the welcome and syllabus. If you haven't looked at it yet, please do, especially that the support hub for tutoring and our classroom Zoom are right there above the calendar as links. And then we are in week 3, so we want to go to the week 3 book. The books always have textbooks, videos, whiteboard, to-dos, my open math. At the top, there's the list of which GED salad bar math topics we care about now. We have 2 books. The OpenStax one has a table of contents. You can see what sections, like 3.1, you would want to read. And it's an okay book. It's free. We get what we pay for. It's better than nothing. The really nice one you need to log into. And so I've paid for an account that we can all share. But since I've only paid for one account, I'm going to ask that we use it one at a time. So if you're doing some homework and you want to look at this, please do. That's why I paid some money for it. But send me a text or an email. Text is probably easier to say, hi, I'm using the book. And that way, if somebody else does homework coincidentally at the same day and time of day as you do, then I'll know that and get another copy if I need to. I will put into chat the login information for the better textbook. Okay, there we go. So if you were in Moodle, you can see that. Did you just get that now? Okay. The way that this textbook publisher works, you can look at anything in chapter 1 in any textbook for free. But if you go into, say, chapter 3 about graphing, it won't let you click on those unless you've logged in. So this textbook is wonderful because let's say I'm actually chapter 2, solving linear equations. That's a good thing for this week. When I get to an example problem, there's always 2 buttons. The orange one is the give me another practice problem that resembles this, so you can see if you're getting it. And then the TV shows you 4 different people, at least 3, usually 4 different people, one of them in Spanish, going through this problem. So it's kind of like Harry Potter where the pictures move and show you what's happening as you're reading the book. It's wonderful. So everyone likes this book better because not only is it kind of colorful and has better layout, but you get videos that fit exactly what you're doing. So do that, log in with my son's account. I just had to pick some account to pay for and use this book, it's wonderful. Okay, videos, besides the videos in that great textbook, I've gone through YouTube and picked out all the best YouTube videos I can find for our math topics of the week. So you don't have to waste your time finding where the good ones are. Sometimes I mention individual videos, sometimes entire playlists, but that keeps it efficient. And you're never going to watch all of these because there would just be hours of them, especially if I put a playlist. But you'll find which of the YouTubers you like best. Some people really like math antics because they're kind of have antics, and some of them really like math is power for you because the way he handwrites and explains things might be clearest or something. So whatever works for you, you'll kind of figure out what ones to do. We have a whiteboard, so each week we have a whiteboard and you can click on it and go there. To-doodles are things that we can use to explore old topics, to review foundational things. I'm not going to worry about that now. And then your homework is the My Open Math. At the moment, I have grading turned off. You can't see a summary of your My Open Math work. You can just kind of see in each one what your score is. And that's because of the way books work. So most Moodle classes, the main page is this gigantic annoying scroll, and you have to keep scrolling down and down and down. And so I'm using the books to avoid that. Hopefully everyone thinks that's a good idea by the end of the class. The problem is anything in a book, the grade book sticks on the far right. So all of the things for the future weeks, where in the hidden teacher side of Moodle, those assignments exist, even though for you they are turned off, then they mess up the grade book. So until we just get a little farther into the class, then I'm going to keep the grade book turned off because I'm not quite sure what it looks like to you as students. And if it's as ugly as it does to me with all of the homework you haven't been assigned yet in front, and then you have to scroll to the right forever and so on. That's okay. This is not a graded class, but you want to do well on the GED. So your goal with the MyOpen Math is to spend enough time on it that you feel confident with these things. And that means you should never spend long on any problem. If there's a problem that is making you stuck, then if it's something that you think the resources you already know just where they are can help you, then you use those resources. Oh, I was just reading about this in this textbook section, or I just saw this video I liked on the YouTube ones. I'm going to watch that video again. But if you don't already know where the resources are to help you with that problem, then just write it down. Homework J, number 5, asked about it in class. Because somebody else will also want to know that. And there's enough different things we're doing, because the GED is such a random collection of math problems, that work on other things. Don't waste time trying to teach yourself something as if we didn't have a class, right? Okay. And I guess along with that, if something just seems like you got it and you're bored, then you don't have to finish these. No one is going to look at your grade and say, oh, you didn't finish section J or something. If you need, I think it only lets you try them like twice and then it just starts giving you answers or something like that. I can change how that is set up. So if you don't like any of that, let me know. I just keep it the way I'm given by my boss. Okay, so that's basically what we do. We have a syllabus, pay attention to that, and then for each math topic, then you have textbooks and videos to look at outside of class. We use the whiteboard and to-doodles in class, and then you do homework to make sure it's actually working. Questions about any of that before I start the math topic? No? Okay, let's start. So I am in the whiteboard for today. I'm going to put that link in chat so that you don't have to go into Moodle and find this thing I'm clicking on. There, chat. There you go. Okay. And it should be true that write to team, copy team invite. So if it's not letting you go there, then I just put a link in chat and then I'm going to grab my email and it should email me if you have issues. But this should let you be officially part of the LCC Bureau group and then you can edit this. So holler if that's not working. And edit. So show me it's working. I'm going to summon everyone to my view because this is an infinite whiteboard. And then grab your pen over here. And get some sort of pen and like write something on the board. Hi, like that. So show me the whiteboard is working for you so we can all work on this together. Is anyone getting error messages? No one is text is typing that it's not working.
Do I have to log in?
You have to log, I don't know, my computer is logged in. What is it asking you to do? Sign up for free? Yeah, it looks like you have to. It might just let you use Gmail and then put in your LCC Gmail.
Last name and the first name of the first name, and then at my name, my.name.cc.uk. What's the email?
Well, I'm sure the world's tiniest hello, but I don't know how to change it.
Yes, I'll send it.
That's fine, okay, I'm gonna put this up there.
Name, CC. What do you need?
Okay. Bigger. So here's our topics for this week. Some of them we've done before, some of them are new. Identify key features of the coordinate plane. That one we did on Tuesday. We talked about the game Battleship, where you go over and then go up and see where you are on the coordinate plane. We talked about how coordinate planes are kind of like number lines with just a rabbit walking on them, but you have two directions instead of one. Things like that. If any of this is something you want me to review more, especially Adriana or Brenda, because you weren't here, then let me know. We talked about ordered pairs. There was the we're not Superman thing. We have to go sideways with the first number and then up or down the second number. We can't just go up first and then fly over, because that's not how it works. We talked about function notation and how to plug things into functions. We mentioned what X and Y intercepts are, but we didn't really use those to graph the equation. So as a review of all of this, I'm going to scoot over a little bit. And I put a table, the homework with a nice book. So first, let's finish the table. Y equals 2x plus 1. That's what I'm doing here. So if I plug in 0 for x, what comes out? If I put in 0 for x, what do I get?
-1.
-1. Everyone agree with Anthony?
No,
2 times 0 is 0, and then I subtract 1 and I'm in debt 1. Okay, if we put in 5, what do we get? 9.
none.
Right, okay. Although if this isn't making sense, I need to put in something and I get out 7. What would I put in?
Or
4.
Or I need to put in something and I get out 3. What would I put in?
2.
Everyone okay with those?
so
Okay, so if that happened quickly, great. If that's something that's slow, then just practice it some. That's why you have my open math. Do you have to be quick at those for the GED? No. But you know, if you can get a little faster, all the better. Okay, now I need to plot these points. So 0, -1. I'm going to go sideways 0. So I'm not sideways at all here, just stay right on the y-axis and down 1. So there's my first point. Somebody else do the other 3 points. Pick a point no one else is doing. Go forward. Someone can write 4-7 very neatly. Remember, you don't actually have to ever write with your pen. There is a text tool. If you want to type out the text of a coordinate pair, that's often easier than trying to make it for the next. Okay, I will try and draw our line. See if I can do this one. No, that's the one. And cheat, so. Okay, well, not the best line, but not the worst. Okay, forgive my artwork, there we go. Everyone okay with this task? You could do it again if somebody asked you to.
Yeah.
Once we had a line, then we could say, oh, this one was the 5,9, and below it was 4,7. So I can draw a little triangle here and say it goes up 2, but only sideways 1. And people will call that rise over 1. And this particular line, the rise was 2 for every 1 that it went sideways. Every 1 that went to the right. And the full name for rise over 1 is slope. How slope is the hill. Okay, does that ring a bell? Or if you weren't here last time? You've seen this before? Okay, call her if this is new, because I don't know what, especially Brenda and Adrian. Okay, back to our list of topics. By the way, if you want to scroll sideways, hold your right mouse button down and move around instead of the normal mouse button that clicks on things. Okay, so that was the so what are the intercepts? I didn't actually do that part. So the intercepts are where they cross the axes. This one, it would cross at 1, 1/2. I'm sorry. 1/2, 0. And that 0, -1. So one of the intercepts is where it crosses the y-axis. And the other intercept is where it crosses the x-axis. Could I graph something just by being given those two? Sure, I could. I could say. Okay, there's 2 intercepts. 4, 0, and 0, -3. Show me where those are on the graph so I make sure we're not confused. Great, and then I'll try and do my best to draw the line. Okay. Ta-da. Again, everyone can do this task if they wanted to. And you can do it backwards. You could go from the graph to read off the intercepts. Okay, all over again if this isn't just easy to repeat. Okay, we talked about slope as that rate of change, rise over run. Remember that if your line points down, your slope is negative. So both of these that we did have positive slopes, but they don't have to have positive slopes. If I had a different line and it was a rise of 3 but not a positive 3, a negative 3. Or run whatever that is, 1, 2, 3, 4, 5, then that line. Would be a negative, either numerator or denominator, either one, and if you have either of those negatives, you could also say the entire fraction is negative. Okay, all of that still review, holler if it's not.
Now, if you see an equation that's a negative fraction like that, to solve it, wouldn't you wanna just take that negative symbol and put it on top, of the numerator?
Usually it's most helpful to just think of the negative in front of the whole fraction, but it kind of is the situation. If the equation was, falling, I was dropping a rock off a cliff or something, then you might think every 5 seconds it goes down 3 feet because it's a balloon and not falling fast or something. I'm not thinking of a good example.
Well, I guess it's like if I was to look at that and be like, oh, tell me what the slope of negative 3/5 is, I think my knee-jerk reaction would be like, okay, well, it's gonna be -3, -5.
Yeah, no, only one of them is negative.
Right, so
Negative
that's what I'm
divided
saying,
by-
so should you always apply that negative to the numerator?
It doesn't matter.
Oh.
It's there's 2 answers to that. One is that part of getting quicker and more fluent and employable at math is seeing all the things at once. So a great example of that as a tangent is if I say 0.2 and 1/5 and 2/10 and 20%. Those are all different names for the same thing. And so part of being someone that, like, businessmen want to pay you to work for them is seeing one of these and your brain thinks of all of them. Maybe 20% isn't relevant in this situation, but maybe it is. Does that make sense? So similarly, if you see -3/5, then that's a negative of a fraction. It's also -3 divided by 5. It's also +3 divided by -5. And in certain situations, one might be more sensible than others. Are we moving down as we go make forward progress of 5? Or are we going up 3 as we back up 5? And that's kind of a real life what's happening that I don't know. So I want my brain to be open to thinking of both. Okay, I was just pointing at the whiteboard for the people who are in Zoom. We were saying that we could think of this as I'm going down 3 as I went forward in time or distance 5. Or we could think of this as we went up 3 as we go back in distance or time 5. Those are both ways of thinking of exactly the same picture. And based on the real life circumstances, one would be more helpful to think about than the other. But you haven't told me what the real life situation is. I just want to keep my mind flexible and think about maybe it's this, maybe it's that. Okay, more philosophy than you were wanting. Okay. So the slope formula, find the slope of a line or graph by using 2 points or by using the slope formula. The 2 points we did, but we only have done it so far with a picture. I drew a little triangle, whether on that graph or the other graph or the other graph. You don't have to graph it. You don't have to draw a little triangle. If you just give me 2 points, like let's say these two. Oh, that one has a negative. I never like the one with negatives. I don't have to. I have those points, then I can just say, what is the change in y? these two, that was the 9 minus 7. What's the change in x? That's those, 5 minus 4. So I don't need to actually see the triangle, I can just know it's there. Even though we saw that, yes, the triangle is really right here. And then the follow-up question is, what happens if Adriana picks the 9, 5,9 as the first one, but Victoria picks the 4,7 as the first one? And it doesn't matter, because if you did 7 minus 9, you just get a -2. And the 4 minus 5, you just get a -1. If I reversed which. If I reversed which ones. I would just get 2 negatives. And then when I put the -2 over the -1, I get the same thing, because negative divided by negative, the negatives cancel out. So you can't pick wrong, just pick 2 points, and as long as you keep the 5 and the 9 together as first, or as long as you keep the 4 and the 7 together as first, it's gonna work out. Once I have the slope, people like to write the equations in this form that we have up here, this slope intercept form, where the slope is right there. It's the number being multiplied by x. And we did a to-doodle project on Tuesday where we saw that if going down a list of progressive steps, a pattern, it was +3, +3, +3, that turned into a ×3 for the actual rate of how things changed. If it was a +2, +2, +2, that turned into a ×2 in front of the letter. So hopefully that gave you some kind of intuitive sense of how that slope works. So if you get the y equals mx plus b, then you can just look at what number is next to the x, and that's your slope. Ta-da! Show it to you. Okay, is all of that reviewed? Do you want me to do more examples? I have not done enough examples if this was a new thing and not a review topic.
Okay.
Okay, we will do more of this. Okay, find the slope and y-intercept of an equation in slope-intercept form. Let's talk about that. Grab. So here's some things I copied to have nice font. Slope is rise over run. What we call slope intercept form is y equals mx plus b. That b works out to be where it crosses the y-axis. So in the equation that had -1, it crossed at -1. And so on like that. That's the equation that you will see the most, partly because it makes these kinds of problems work on a timed test. They can say, if we give you the equation of y equals -2x plus 5. By the way, go ahead and start drawing that over here. Then I can say, what's the slope? And you say -2. Or I say, what's the y-intercept? And you say 5. So if the purpose is to have a test, this is convenient for being on a test. It's also, as we saw with patterns, the easy way to turn patterns into equations. This is the pattern of something is getting too smaller each step of the pattern. And we started with 5 of them. So I have 5 candies in my bag. Every day I eat 2 of them. When do I run out of candies? That kind of problem. Oh, I will help. So. What is easiest to put on this chart, and actually pull people towards me? What's the easiest to start with, the -2 or the 5?
5.
The 5, so I'll count up 1, 2, 3, 4, 5. So here is my y-intercept. I can even label it. So 0, 5. What do I do with my -2 once I have a sort of launching point to move off of?
So if -2 is your slope, wouldn't that be -2/1?
Yep, I could rewrite it certainly as -2/1. So it's a rise, which might actually, I could call a fall, because it's going down. Over 1. Okay, so here's 2 down, that's fine, now I'm at 3. Where do I draw the second point?
Go back to down 1 and then draw a point.
Yeah, I need to run 1. I went down 2 and now I go over 1. Everyone okay that this is my second point here at 1, 3? No, yes.
No, I don't know where the one is in.
Because -2 is the same as -2/1.
Okay.
So if I wanted a fraction, I could just put it over 1. Or any whole number into fraction. Once I have 2 points, I could do more. I could say, again, I'll go down 2 and over 1. And get to 2, 1. But I don't need more than 2 points. Once I have 2 points, then I can draw my line. Assuming I can actually draw. Because once I have 2 points, that determines the line that goes through it, with no more choices left. Let's do another one in a different color. Let's say, show me y equals 4/3 x minus -8. So what's the first point I would draw for the purple line? We can do it on the same coordinate plane, or we could make another fetch.
You'd start with -8.
So 1, 2, 3, 4, 5, 6, 7. So this point here for the purple line is 0, -8. Everyone okay with getting the -8 off the end of it there?
Yeah.
So now I want to go over 4. I'm sorry, up 4 and over 3. I have to say it the right. Yeah, that's about it. And again, how is my artistic skill? Reasonably good. Okay,
So would this, so after you drew the line, would this line technically be considered as going down or up?
this line goes up because as x goes positive, y also goes positive.
Gotcha.
So the story for the purple line might be something like on New Year's Day, I was in debt owing money to 8 different friends. I borrowed a certain amount from 8 different people. To do all my holiday shopping. And each week, I get enough money to pay back one of them and a third. How many weeks until I can pay off my holiday shopping debt or something like that? I start in the hole, but I'm going up. Whereas the second one, again, is I start with, the black line was something like I have 5 pieces of candy and each day I eat 2 of them. Some story like that where I'm going down, even though I started positive. So that's the equation format we'll see most often, but that's not the only one. In the middle of the screen, we see what's called the point slope form. So if I had a fraction, one moment. Actually move this out of the way a little. If I had a fraction that was V equals D over T. Velocity is distance over time. I could multiply both sides by T. And then that would move the T to the other side. Is that okay with everyone? We did that the first week of class. Right, I'm doing a times T to both sides. And that makes it cancel out here and appear next to the V on the left-hand side. Holler if I just lost you.
Definitely.
Right, okay, let me make more steps then. Oops, that's not an eraser.
Isn't that how you calculate speed?
Yes, I'm using speed because I'm thinking that it's probably easier than what I'm about to do after this.
No, yeah, that's.
Okay, so if my speed is 30 miles in an hour. And I'm driving downtown, and I give myself more room. Then I can generalize that. So in general, velocity, I'm gonna call it speed. You don't care about velocity, this is statistics class. So speed is distance over time. So far, so good.
Yes.
Per hour, feet per second, something like that. So if I multiply both sides of this equation by time. Then what I get is speed times time. Equals distance over time times time. I can take the time here and make it time over 1, because any whole number I can put over 1. And then it cancels off. Goodbye time on that side. And I just get speed times time equals distance. And that you see all the time in real life also. If I'm driving 60 miles an hour and I drive for 2 hours, I go 120 miles. Everyone okay with all of that now?
Makes a lot more sense, yes.
Okay. I can do even more steps if I need to. We're not in a rush. So we're doing the same process, but with slopes. So I'm gonna go back over here on my whiteboard. And we had slope is rise over run. I'm gonna multiply both sides by run. And I get. Oops, one moment. They load it the other direction. Rise over run equals slope. And we wind up with the runs canceling out. And the rise equals slope. Times run. Everyone okay with that, even though I wrote fewer steps? Is the connection between the two of them clear enough?
Why don't you do times rise?
Because I want to make the denominator go away.
Okay.
So before, I had to multiply by a time to make the denominator go away. Same thing here. If I multiply both sides by rise, then I get rise squared over run to slope times rise, which is true, but useless. That's just more complicated. So I could do that and change the slope formula. And then say, well, what actually is the rise? What actually is the run? It's a change between two different y values and two different x values. We did that a moment ago, plugging in two different points to see. And if one of the points, instead of saying it's a specific point, it's just x comma y, then we get that formula up above. So this is saying, what is the rise? The rise is y minus some particular point. And in this case, let's use the point 3 comma 4. Three comma negative 4. So what is the height of that particular thing? It's a negative 4. When I plug that in, then I'm actually going to say y plus 4 because I don't want negative negative. And then the slope. What was the slope of that one? 4/3. And then the run was x minus a particular x, that particular x is 3. Most people think this is really awkward.
I don't disagree. It does look very awkward.
Part of it is what happened right here. A negative of a negative is a positive, and we know that, but it just sort of tosses our brain in a loop to see it again where we're not expecting it. Part of it is that it's like I'm finding the slope twice. I have to know what the slope is to plug it in there. I have to put it where n goes. And I'm also like using the formula to find the slope with a change in y and a change in x. So why am I doing a change in y and a change in x if I already know what the slope is? So there's a bunch of mental gymnastics that goes on. Look at that.
We do another one.
Yes, I certainly will. And it also doesn't work like anything in real life. It's not like I get $2 a month and I started with $10, so that's why is 2x plus 10. Or something like that. And so it just kind of fails in every useful way. But because it's on the GED, let's do more of them.
When we first started, it made sense. Almost always really made more sense.
So. Let's start with an easy line instead of one with a negative slope. Let's look at. How about y equals 1/2 x plus 3. So once upon a time, I have $3. Every day I go to work, I get $50 more after taxes. I never spend any money. How much money do I have? I have some bizarre story. If I start with 3 and every time a step goes forward, I have a half more. Are we with me so far? On the graph, I'm starting at 3. Looking at the y-intercept. And then I'm like aiming again. At what angle does the line come out of that point? It's I'm going to go up only 1 when I go over twice. So I go up 1 and over twice. So there, and there, and there. So that's my line. Everyone okay with drawing a line from the y equals mx plus b type one? So that's the line we're thinking about. What if I wanted to write it in the awkward format? Then I would say it's y minus some particular y. Equals my slope. Times x minus some particular x. All I'm doing on the board right now is taking this thing and writing it a different way, kind of Mad Libs, fill in the blanking. If that helps you, that's why I'm doing it. If not, ignore my blue writing and just focus up here. So which point do we want? Well, we have 0, 3. We also could have a point that's 2 and 4. We also could have a point that's 4 and 3. Which of those points should we pick?
4, 3.
4, 3, yeah, they're all fine. It doesn't matter which one you pick. So I'll
Why
put
not?
here, the 3 here, and what was my slope? 1/2.
Oh, okay.
So you don't need to figure out the other x and the other y?
No, because that's, I plug in the x where it says x, and then I get out something that's the y. But it's awkward. We like when we have an equation for the left-hand side to be just y equals. Right, we want it to function like a machine. You put something in the wood chipper and it goes crunch, 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 and then it punts out y is 7 or whatever. We don't want this side of the equation to have y minus 4. That's like extra thinking at the end. Yeah,
I think you swapped the coordinates.
I said before in the 3. I did. Thank you, Chloe. Whoops. No, I do want that. I did. Good job. So partly it's because I'm tired, partly it's because I'm also lecturing, partly it's because I'm careless. If I haven't said it yet this term, by the time I got my master's in math, I had made more math mistakes of careless arithmetic than you and your entire families will make in your entire lives. You will never catch up. So don't worry about careless arithmetic mistakes. One of the advantages of the GED is since it's multiple choice, it is not mean. It's not going to always have that kind of thing be a fake answer distracted. They are not interested in if you make careless mistakes. They're interested in if you know what's happening.
So this,
That's reassuring.
that style of equation is the same as the last one we did?
Yep, I could plug in an X and eventually solve for Y. It would just take longer.
So how common are we gonna see
I
equations
pretty
like
much
that?
only see it on math tests.
Joy.
John, yeah. So, ta-da, there we go.
Now, isn't there an equation though that we would see that's like y1 and Y2 and X1 and X2 or something like that. Like
That was
later on.
plugging in at two particular points to find the slope, so that was what we did over here. Where was it?
That,
That's, let's plug in two particular points and subtract them. Here, well, I need to zoom out and see what, where did we, here, that one. Right, we were plugging in two particular points, and it didn't matter which two, as long as we made sure that one was the first one, and then the other was the second one, and we kept that consistent. Now, there is something that you will see even less, but I'm gonna be good and show you. Called the 2-point form equation of the line. And you say, oh, there's like two different points, a Y1 and a Y2, and I have to plug even more things in, but you will never see that. This is like even worse than what we just did. And there's
Will
what's
that be
called,
on the GED test?
I've never seen it. I've only done ready GED, but I would be very surprised. And then there's called the intercept form, where if you just look at a line and you know both intercepts, then there's a form that takes advantage of that. X over your x-intercept plus y over your y-intercept equals 1. So this, oh, go away, box. So this right here, if you know the A and the B, you can write the equation for the line almost instantly. On the other hand, you don't have to remember this, because if you know the picture, you could say, well, let's just use y equals mx plus b. We know y. We know the b. What's the m in my picture?
so. Oh.
How much does it go up and down?
1.
No, how high is that red point here?
Oh, is it 1/2?
No,
What was B?
b, right? The height there is b. That's what this b means.
But we don't know
Oh.
what B is yet.
But we're going down, actually. So it's a negative b, and then this distance here. I'm just covering it up to be mean.
Oh, because that's the Y.
That's the a. So our rise over 1 is a negative b over a. Does that make sense now that you see it?
Yep, I was overthinking it.
Yeah,
Cause it had a 0 at the bottom, so I'm like, oh, well, it's. Let's see.
so if you can remember how to do what I just did. Then you don't have to memorize the second formula. In some special case that only works right now. Most graphs aren't as nice as this, where you can see both intercepts on them. And because in real life, most graphs are something like what we started with, where there's something like this, where, oh, I have 4 of things to start with, and then I get more because I'm earning money, or time is going by, or something. And what's the x-intercept was not something we think about well. Right, it's like backwards in time, or before we started measuring, or things like that. It's not part of your story. The story is that you start here and get bigger. So the special case, yeah, if you like special cases, you can memorize the special case formula. It works. It's just not, wide. You can think about that just as easily with a negative b over it. Or if it was the other kind of graph. Now the negative is on the bottom. But that doesn't matter, it's still. Right. No, it's positive now, because this is a positive. Rise and a positive one, I am confused myself. Well, it's a shirt, I'm not doing that, okay. So it could be positive, could be negative, is the line going up, is the line going down? Okay, where were we before all of that terrible stuff?
You were showing us another way to write y equals
Yeah.
mx plus b.
Okay, so. Find the slope and y-intercept in y equals mx plus b form. Sure, we just did that a whole lot. That was the easy one that didn't make our brains hurt. When we graph a line with y equals mx plus b, we did that a lot. That also didn't make our brains hurt. Then. Write the equation, I'm skipping these two, I know I'm skipping these two. Write the equation of the line in either slope-intercept form, y equals mx plus b, or point slope form. That's the y minus y1 equals mx minus x1. By looking at the graph, by looking at the slope and the y-intercept, by being given a slope and a point, by having 2 points on the line. This one we're saving for last, you will never see that. If we don't get to it because it was a snow week, that's a great thing to skip because of the snow week. So, but hopefully all of these four, even though what we just did hurt our brains, you will be okay once you play with it a little. Going in between, going back and forth from, I'm looking at a graph, I'm looking at y equals mx plus b. I'm going from a graph to this awkward form. I'm going from the nice form to the awkward form. Somebody gave me the awkward form. I don't like it. Let's go back to the graph or the nice form. Okay. Just like we sort of mentioned before, part of being good at math is by when you see one thing, you can get to the other equivalent things if you did that. Okay, it's 7:10. I went over a little. Kayla, are you with us? Do you need a break for dealing with kids? Minutes past her toddler's bedtime.
I can still follow along. It's okay.
Okay. I know, I'm the audio book that puts your kid to sleep, probably helps him fall asleep, right?
I have headphones.
Okay, so the part I skipped over, which will get us at least caught up, but not really caught up because we're a week behind because of the ice apocalypse, is this part here that I made a parentheses, apply the problem solving process to word problems. And either use the equations or use the graphs to solve them. So now we need to talk about word problems. Anyone want more other things before we go on to word problems?
Well, I hate word problems, so I think that's right where we need to be.
Okay. Okay, I'm going to skip all of that stuff. Okay, let me move this a little. Okay, here's my favorite word problem ever. Do you have a favorite word problem ever? Okay. So a square has perimeter of 48 feet. What is its area? Hopefully all of these words are ones you've heard before. But this is probably a problem that you can't just look at it and see the answer. I have this problem even though it's not about graphing, because for most people, it's a very visual thing. It's not a hard thing, but it's a good one for talking about the process of doing word problems. So I'm going to take a break from y equals mx plus b. just talk about the process of doing word problems. And then. Back to why it wasn't X plus B. Does that sound good?
So. Perimeter is when you add all the sides.
Perimeter was
of
adding
a
all the
square,
sides.
So you wanna divide the 48 by 4.
You're getting ahead of things,
Oh.
but you are accurate, okay.
Just kidding.
I do want to emphasize that it's 7:15, if you need some sugar, grab some sugar, if you need bathroom, do that. We could take a 10-minute break, but. I think I'd rather do more word problem examples. So if you need a break, take a break.
The perimeter adds the sides and then area is length width.
Alright, so determine what you're looking for. So what are we looking for in this one?
The area.
An area, so. If we get something with a name like square feet. Then we've done it right. If we get something that with an answer like linear feet, we've done it wrong. And things like that we should have in our brain. Draw a picture, okay, I will go to my picture tool. And
Oh,
I will
area.
get a square, okay, now we have a square,
Sorry, area is always square feet, right?
yeah.
Yeah.
Okay, name things. So I don't really have much to name in this problem. Sometimes I do, I want to name
Square.
like, months and years or things like that, but this is just sort of, hey, there's a square. Make equations, what do I know about squares with perimeter and area, what equations should I write? And now I'm thinking, I actually do need to name things, because I want to write. Something about this square. Do we like S for a side? Do we like L for length? Do we
So,
want W for width? Like, what are we naming on my shape?
I mean, you could, yeah, you could do width and length. for sure.
Let's just start with that.
So length and width, by the way. With length, whoops, what happened to my? Here, tools, back, I think to make tools.
The 3 connecting at the bottom.
And I just wait patiently. Oh, so I will always write length and width in cursive. Because once in my personal math history, I wrote the L not cursive, and then later in the problem, it turned into a 1 and I got marked down and was sad. So by habit, length is always L with a cursive. Try now, reconnecting. Rapidly. I hit reload on the web page.
Yeah, it says I'm offline now too, trying to reconnect. Oh, connection restored for me.
Okay, go Miro. Okay, so there's my length, almost a W. Okay, so what's my perimeter going to be?
Perimeter is 48.
It is 48. formula wise, let's just get that part first.
Oh, length plus width plus width, the length times, or length plus width, but yeah. However you wanna put that word.
Okay, and area is length times width. Now, that's for a rectangle. We have a square, so length and width are actually the same.
Oh,
So we can make this simpler for a square. So a perimeter is just 4 times the length. And the area is length squared. So rectangle. Square. Okay, everyone with me so far? This is a great way to think about it, right? It's perfectly normal to not jump right to these. But to say, oh yeah, what I really had drilled into my brain was the rectangle formulas, and then I'm realizing I don't need to write as much because it's a square and so on. So far, so good. Okay, now I figured out what I'm looking for. I've drawn my pictures. I realized I did need to name something. I needed to put the L and the W on my pictures. I made some equations. And now I need to solve them, so let's plug things in, and we're doing what Anthony had done long ago, but now we can write what's happening. So this is that the perimeter is 48 equals 4 times L. Divide both sides by 4. Get L by itself. And there we go. And then what's the area? Area is 12 times 12. 144. Equals 144, and that's a word problem, so I need to label my answer, so square feet. I might even say that, look, this one is 12, that's also 12, and so the area is 144. Okay, questions about that problem we don't care about? The process we care about, square and. So let's do that same process over here, but now with y equals mx plus b type things. So my first problem is. I have to move everything down. Okay. Okay, good enough. So you saved $500 today. Good job so far to buy a new computer. And every month you can set aside 75 more. We need some actual question. How many months before you could buy the computer? How big a computer can you buy after 5 months? Something like that. What question do you want to ask?
Oh, there's not an actual question attached to that?
No, I want you to invent the question when you care
Oh.
about it more. It's the IKEA furniture style, what math would be. Somebody's,
How much money would you have in 1 year?
okay. How expensive a computer would you afford after saving 1 year? Okay, everyone like our top problem here? So. How would I write that as an equation? Uh,
500 plus 75 times 12.
yeah,
My brain sees it.
No, that's how mine sees it too, but he wants an equation.
no, that's fine. This is great. 500 plus 12 times 75. Everyone happy with that? We could even see what that is, Desmos calculator.
75 times 12 is 900 and plus 500 is 1400.
No, one calculator. I know it doesn't matter, so 1,400. For the recording, I want to have the calculator. Oh. Now, what happens if we change it? So instead of for saving one more year, we make it some variable amount. So now we will go to our text box and say, how expensive could a computer could you afford after saving X months? So now I can't put in the 12 because we're not sure it's 12.
It would be 75x or x. But,
I mean, it's 75x plus 500, right?
right.
Yeah, so instead of the 1,400, that's now some amount.
Okay.
And instead of how many months, that's now my variable amount, right? It's still true that every month we get 75. And it's still true that on day one, we had a $500 savings to start with. Can you see this is y equals mx plus b, even if we wrote it out of order? Right, what the multiple choice on the GED would say is y equals 75x plus 500, maybe with or without dollar signs. You. But we just turned a word problem into an equation. Could you graph this if you wanted to? Sure, we could graph this if we wanted. Oops, no, that way. Okay, grab our graph. We could say that each line is 75. Why not? I will make it easy for myself. And every month they just go up one spot, right? So where do I start at? 75, 150. 225, 300. 375. 425. 500, did I really do that right? 1, 2, 3, 4, 5, 6, 7. No, 525, I didn't think it was gonna come out either. So this is 525. So I really crossed just a little below that, that's my 500. And then each month I go up one of those.
It's just past the 6.5.
There. So that's my growth line, right? Does it help to graph this? No. But you could if you needed to. Okay, next one. A recently started food cart business has 11 regular customers. Each week it acquires 2 more regular customers. What question are we asking? How many what?
The food cart,
Oh, yeah, it should be a food cart typo, okay.
how many customers after a month?
How many customers are regulars after 1 month? So
Like 3 months, I mean.
I'm gonna say 4 weeks instead of a month, because we had weeks earlier. So again, we could do this as a specific one. That is again what our brain most naturally does, is not think with variables, but with specific numbers. So this would be that it started with 11. And we have 4 times 2 more. So 11 plus 8 is 19 regulars after those 4 more weeks. And for my labels again, this is weeks. This is customers. And this is also the customers. Regulars. Everyone okay with what I just wrote?
Mhm.
And again, we're gonna say, but what we want to also be able to do is, what if we don't know how many weeks? What if it's a variable amount? Exactly the same thing happens. So now where there was some answer, we just have a y, we're not sure what that will be.
2x.
Where there was the 4, that's our x. And everything else is the same. And if you were looking at this as a multiple choice thing, they would write it as y equals 2x plus 11, because that's the format. Could you make a graph of this? I don't think we need to spend time in class on it yet again, but you could. Maybe I'm wrong. Anyone want me to graph this? You can. You want me to put the graph on it? You could graph it.
Polite cats.
Okay, I want one where things are going down, because that's part of what makes it mentally tricky. Oh, I am kind of being sloppy. I am not going through our list of things here as I'm talking about it. You want me to highlight all the things we're doing on the process? Let's do it at least once.
Let's do it on the next one.
So
Why not?
with the food cart, did we know what we're looking for? We're looking for like regular customers, and it's going up. Right. Drawing pictures, we didn't need to draw a graph. That's okay. Do we need to name things? Well, we sort of named that the weeks is what's becoming the X. We had that happen in our brain. Make the equations. This was a great way to do it with 2 different steps. First, we made a specific case, and then we made the general equation with the X's. It didn't take long. If that's what we did on the GED, that would still work fine. That's how our brains work best. Solve the equations. It didn't ask us to in this case. But it could say, use your equation to find out how many customers there are after 17 weeks. And then we can plug 17 in for X, 2 times 17 plus 11. And get some answer, right? It could ask us to use the equation as well as just make the equation. And check your answer. Plug it in and see if it
Or
works.
just do it with the calculator, yeah.
Okay, so here we go. So a used car is bought for 26,000. And its value decreases at 1,200 per year.
Sure.
What question do we want to ask about this car?
What is the car's value in 2030?
What is the car's value? So in 7 years. So what are we looking for? We're looking for a dollar amount. If we messed up because we're taking a test and have a brain fart and we get the answer of 5 years, no, we need a dollar amount. Draw a picture. I'm gonna, at this point in the problem solving process, just have a little image in my head. Is this the kind of graph that looks like this? Or is this the kind of graph that looks like that? Was it going up or down?
Second one.
The second one. Everyone okay with that? So when we're at this step in the problem solving process, I'm just gonna realize this is the picture that's going on, even if I don't need to draw it carefully. Okay. Name things. I like what we've been doing. When we get to this name things step, I just want to kind of practice with a specific case. So we did that. What's its value in 7 years? So what should I write? How do we get the specific case of 7 years?
Wait, what do you mean specific case of 7 years?
Like I need to put a 2600 and a 7 and something on my paper.
1200 times 7. But 2600 minus 1200 times 7.
Okay, why am I by habit putting the 7 in front, even though you said that it would be times 7 at the end? They're the same, it doesn't matter whether I do 7 times 1200 or 1200 times 7.
So multiplication is splitting them up. I don't know, it's a guess. Who's splitting it up?
Let me be clear, I could also write this as what you said out loud, 2600 minus 1200 times 7. So why would I want to put the 7 on the left instead of the right, even though it's exactly the same as far as the math is concerned?
So you're confused. And minus 1200 from 26.
It's because when we're talking about slopes, I'm thinking about that this is how many copies of that. Just the way my brain works, yours might be different. I like the first number, the one on the left, to be like 4 copies of 2 customers a week. Right? Or X copies, some variable amount of 2 customers a week. So I just get problems wrong less, I make careless mistakes less if I follow that pattern. So I think in the situation, which thing is how many copies I have, and that's the one I'll put on the left when I multiply. So it's not more right, both of these things are equally correct on my paper. But just so I don't make careless mistakes, then the ones that's how many copies. Is the one I put on the left, and then the each copy. Is the one I put on the right. You don't have to do that. But if your brain works like me, then you might as well get to that habit. Okay, so what is the answer? 2600 minus 7 times 1200. Negative 5800. Something's wrong. We picked a month that's going to be, whoops, 26,000. There we go. So 17,600. Or if I was over here, 17. Okay, what if we changed it? What is the car's value in, not in the 7 years, but after some number of years, we don't know.
Well, it's a good thing you put them in the right order there, so you can put it as 26,000 minus X times 1,200.
Whoops, yeah, you are saying it right, I am writing it wrong. Equal and so on, or if you were on the GED as an answer, to circle.
Take away.
By the way, minus 20 that plus 26,000.
So why couldn't you do minus 26,000 and leave the 1,200 positive?
Because that would be that the value of my car started out some negative amount somehow. And it got more valuable over time. So. Questions about this one? The negative can be confusing.
Will it be wrong if? Never mind.
I made another one, but I think we're getting repetitive. Let's do something else with our last few minutes together. Okay, so when we go back up to our list of things, then we've pretty much done all these things. What we haven't done is talk about parallel and perpendicular lines. That one I doubt you will ever see. So since we lost a week with the ice, we'll just pretend that didn't happen. So let's look at. Actually, let's look at the textbooks first. If you wanted to look at the textbook after class, then linear equations. A bunch of things there. About solving things in this y equals mx plus b format. And kind of how formulas work and some applications. Don't worry about the inequalities. So y is less than 4x plus 5 instead of y equals 4x plus 5. That's something that is put in these books for historical reasons, but the GED stopped asking about that kind of question, so we can skip over it. And then in chapter 3 with graphing, it talks about coordinate pairs, solutions to the equations, how to graph them, and then more about intercepts and slope. Can you find the equations? And again, with inequalities, y greater than 3x plus 4, don't worry about the inequalities. That's just their kind of, that's how textbooks are. If you're doing the MyOpen math, then we have lots of different homeworky things. Intro to functions. Can you plug things into functions? Can you solve for a certain speed at this distance and time and so on? Plotting points. Can you graph things from tables? That's how we started out at the beginning of today. Can you do stuff with slopes and intercepts and slope-intercept forms? Can you write equations for lines? There will be a tiny bit there of that awkward point-slope form. Not point-slope form, slope. We've been forgetting the name for it. Terrible one that nobody uses. Yeah, point-slope form. I was right. So it'll be just, that's where they're hiding a little bit of confusing one. And then learn more about point slope form. That one also gets its own category just because it is confusing, but again, don't spend too much time on this. You might not see it on the GED. Focus on those upper things. Okay. What do you want to see more of? We have 5 minutes. If you need to go, you can go. I'm here to do more if you want.
I was wondering, were you, on the GD? Website, will you give us a pretest to do?
Well, I give you a pretest. No, the office does. So let me show you that. That's a great question. I'm going to make this just a tiny bit smaller so you can see more on the screen. So if you go into the syllabus has all the answers. There's a page there called GED info. And tells you all about things. Notice this part at the top with all the links. Rebecca from the office is amazing. So she's made a slide, she's made a video, she's kind of walking you through this process. But what you need to do is first make an account at the GED website. Then you need to link that to LCC. Once you do that, then the ABSE office can give you a code that will give you a free practice test, provided test. As part of the benefit of you being here, if you don't have to pay for it. And you can take it whenever you want. It's just a practice test. So if you're just curious what you want to do, and maybe this is mostly the first time about stage fright anyway, sure, go ahead and take one. And it doesn't cost the ABSE office that much. It costs us a little bit, but you're worth it. And then once you study more and think that you're really ready, then again, get another practice test, code, and take another one. Once you do some practice tests, then it gives you a color-coded score. And how high the score is that you want depends on what your goal is. So likely to pass is sort of in the 160 and up range, maybe 152 if you want to cut it close. But what a lot of people care about is this picture, where you can see which GED scores at the top qualify you for which credit math classes. So if you want to save money and skip math 65 and skip math 95 and go right into 111 or 105, then you need a GED score of 165. So if you're doing a practice test and getting 150, that's enough to get your GED. But maybe you want to do some more practice and some more ready tests until you're up to 165, because that's your goal. Or maybe not, maybe you just want the GED, and if you could get, mid 150s, then go ahead and try and take the real GED. But the real GED, they don't let you repeat as often as you want. You have to wait a certain amount of time before you repeat it. So, once you pass it, you're not allowed to take it again, because you have your GED score.
Yeah.
So don't take it too early if your personal goal is something that a higher GED score can help you on. And I can help you with the process. If you can't remember, like, on the website, how to click where or so on, then we can just Zoom together and you share your screen and I say, click here and help you. But I can't give you a code. The office has to give you the code.
Okay. So I was just wondering. Good.
Yeah,
I guess
speaking
we'll-
of that, office hours. So the way everything works at LCC, I have to pick my office hours before class actually starts, so I have no idea what your schedules are. So I picked Monday at noon. I'm up on the 4th floor in my office. I can change that. There's nothing special about Monday at noon. When do you want me to be around for you to come do office hours, whether it's physically here or at Zoom? It can all be good. Anyone here when I do office hours, shout now.
You probably care more around the final. Speaking
Well, we
of,
can still get a hold of you though.
Yes, yeah. I tend to be the kind of parent taxi dad, so during this 4-day school day. I have lots of things to do, but most of them don't have a specific calendar time of day. Part of being part-time is I just don't have to go to that many meetings. So, if you want me to do something at 4 in the afternoon, you know, good luck, I'm busy driving my kids to things then. A good office hour is often, strangely enough, evening weekends, because then all of our kids are in bed, for those of us with young kids, right? So many terms that people say, let's do office hours like Saturday at 9. Or, you know, something like that. Just because.
Is that an option for you?
Sure. Doesn't make my wife the happiest, but we'll put up with it. Yeah, so whenever you're gonna be doing homework anyway, then say, let's first of all do a homework group then, and I can help with that. Even if you want to be anonymous, say somebody in class wants to start doing homework Thursdays at 8 PM after dinner, who wants to join that homework group? And then you don't have to worry that someone is joining your homework group because, you know, they like your hat or whatever. Or if you want me to have the office hour when your homework group or your homework time would be, just so that if you get stuck, you know, and they're in Zoom, and say, yeah, Thursdays at 8 is great for me, make your office hours then, and then I bug you if I need to. So once you get your schedule settled, let me know.
What is math 105?
Math 105. Math 105 is math in society. And
useful
it
math?
is,
So like useful math?
it is almost useful math. There's a lot of politics as far as what goes into that class. So in theory, it should be all those things I mentioned at the very beginning, like how not to be poor when you're old and how to use math to have good health and dieting. And how to start your own food cart business and keep track of ledgers and things like that. You know, what's the difference between markup and profit and margin and things like that. It has a lot of that, but it doesn't necessarily have that as quite as concentrated as useful as you would want. It's if you want a lot of it, a 3-term sequence, there's an A, B, and C. And it goes through all kinds of interesting things. If you heard of star voting. So there's how elections work and which types of voting patterns tend to make people happy or not happy, and why we can't have a perfect voting system. There's something called Arrow's impossibility theorem. So it talks about some interesting things like election math that, yeah, they're interesting, but they're not gonna, like, no one's gonna pay you money to do that, and like have a save for retirement, which is actually useful.
That's in that class too.
It's gonna be there somewhere. Because of what happened with politics, a lot of the more complicated calculator stuff disappeared from it. So, some problems, how big a house can I afford is a good example. That's one that's just a little too much arithmetic to have survived in the 105 in recent years. They talk about that a little bit, but not nearly in as much depth as we used to.
Well, that's because the answer now is nobody.
And so, yeah, so it's a good course. It's designed for you to get your math prerequisites done for degrees and programs that don't require calculus, don't require algebra. So.
Oh, wait, say that again?
So the 105 series is for people that don't want a lot of algebra, but need some math requirement.
Okay.
What if like you get more points on the application for doing calculus? What is there like if you scored over
I'm not quite sure what you're asking, Kayla. If you want to get into calculus, 111 would be the farthest that the GED can place. So 111 is the lots of algebra version of advanced math instead of the practical stuff as much as we can without algebra, which is 105. Did that answer your question?
Yeah.
If you want to see the details, you could always go to Lane's website and navigate through the really confusing menus because they keep changing this. Come on, Lane. No, okay, well, if it was working, you could click through the class list. And in the class list, you can see when you click on the title, exactly what's in each class.
Okay.
But for some reason, the Lane website is down and I can't show you right now. That's really bizarre. And I go to archive.org. Look at. Let's see. No, the archive doesn't have to be there, that's this one. Oh, okay.
You should switch that, and it's funny to highlight button.
Jump off the main page to the class digital. Yes, okay, so the main page was broken, but the rest of it is. So if I go to class listings by subject, and we're talking about math. Then I can say, aha, here is 105. What is 105? And there's the list of everything. So problem solving strategies, some probability and statistics, financial math. Is there a 105 something else? No, they are all Z this term. And then what's 111? I could click on that one.
Have a good weekend.
Here we go. Functions, polynomial, rational, exponential, logarithmic, piecewise defined, and inverse functions. So. Lots of output.
Well, that's good to know that I can do, we'll do that.
And if you need to know about the math department, since I taught in for that math many years, then I can tell you about these professors.
Okay. Cool.
There's. No one I will say they are terrible, avoid them, but there are some tips and tricks. A few of them, for example, have very thick Russian accents. And if you are not used to that, then get a study partner before the first class begins, so you can look at each other's notes, because there will be a few things that you're trying to write down that you don't catch. Little advice like that, but they are all great people. We are fortunate at LCC to have a strong math department.
Awesome. Thank you.
Welcome. Okay, we are over time, but I'm answering questions. Other questions? No?
Thanks.
Okay, grab cookies so you drive safe, or stay away from the bus.
Oh, yeah. Okay, one for myself.
Okay,
So if I got a high enough score, I could test into 111, that's what you mean?
one moment, my ears are kind of clogged. Let me stand in front of the D10. Tell me again.
I said, so if I scored high enough on the GED test, I would go into math 111.
You could go right into 111.
Okay.
That was this chart. There, that if you could get 165 or higher, then you could save money and time and skip that.
Yeah.
Okay, I'm gonna stop the recording, but we can still